Hi guys, today we're going to talk about section 8.2, which is all about solving linear equations. So mostly what I'm going to do today is just try and give you a bunch of more examples basically of linear equations and how to solve them, because every one of them is going to be a little bit different, right? So we're going to go through like 10 examples here in this video of just more types of linear equations to solve, just so you can kind of see what approach I would take to solving linear equations. And then we'll also do some of those percentage problems that you've seen in your textbook. I do also want to mention that in your textbook, you'll see as you're reading, the author really likes to show you how to use the graphing calculator in several ways to help solve these equations as well. That's totally fine if you have a graphing calculator and you look at those methods and you like using them. I would definitely learn how to do this by hand as well. And if you don't have a graphing calculator, or even if you do and don't want to use those methods, I wouldn't actually teach those methods even if we were in class face-to-face. So those are just kind of supplemental for you if you want to go through them. Otherwise, this video will help you solve linear equations and come up with ways to do that by hand. Okay? So what we're going to start with today is just talking about, so in the textbook too, it's covered, but I just want to kind of summarize it. Let's see if I can get this to right here. It's just not wanting to. Properties of equity. And all these mean, and the big thing you want to take away from these properties of equity are that you can, when you have an equality, which means you have something equal to something else, where you got something on this side and something on this side, that equal sign will remain true no matter what you do to both sides. You can do all operations to both sides. So that means an equality, which is what we're looking at right there, remains true so long as the same number is added. We can add to both sides, we can subtract, we can divide, and we can multiply. Okay, so basically what you want to realize is that you can do any operation to both sides of an equation as long as you do it with the same number and do it to both sides. Your equality will remain true. So the way I like to think about solving these linear equations is by undoing the operations that are currently happening. Okay, so let's bring up some examples here. So we're just going to go through about 10 examples here of different linear equations. We're going to start off with some simple ones that just have one operation going on, and then move into some that have multiple operations to try and kind of figure out which ones should I undo first. So anytime you're solving these linear equations, it means you have one variable to the power of 1, and you just want to solve for that variable. So here's an example here. X minus 2 equals 3. So what I'm going to do is I'm going to say, okay, I want to get x by itself. Currently, I'm subtracting 2 on the same side as x. Your goal to solve these equations is to get x alone. So what we're going to do is undo the operation that's happening to x. Currently, we are subtracting 2. So we will add 2 to both sides. That will make this x minus 0 equals 5. And we added 2 to get that 0 so that I can say, oh, x minus 0 is just x. And I have the solution right there as soon as I've undone that operation that was happening to x. The answer to x minus 2 equals 3 is that x would have to be 5 to get to 3. And the nice part here is you can check your work every time. Just plug it back in. Our original equation was x minus 2 equals 3. Check to see if the answer you got works. 5 minus 2 equals 3, 3 equals 3, and we must have found the right answer. Okay, so I won't do this checking step all the way through, but that's just a good thing to do, especially as you get into more complicated linear functions that you're solving. Check that work and see if you got the right answer, or if maybe you made a mistake along the way. So what about x plus 3 equals 7? Well, now the operation I'm doing to x is to add something to x. So I will just undo that by subtracting that same thing from both sides. Notice every time I have to do it to both sides of the equation so that that equal sign stays true. Okay, so these cancel, that's why I did it. I'm left with x on the left side, and 7 minus 3 is 4. And we have our final answer. Okay, hopefully that's starting to make sense. Try 3x equals 6. Now this time the operation that's happening is multiplication. Anytime you don't see a sign between a number and x, that is multiplication. So in order to undo multiplication, I will divide both sides by 3. Now the reason that works here is because 3 divided by 3 is 1, and 1 times x can be simplified just down to x. 6 then divided by 3, that happens to divide evenly, so I can give that number. If it didn't, I would keep the simplified fraction or possibly rounded decimal if the homework might allow you to do a rounded decimal, okay? And here that just simplifies because 1 times x is just x, and we have x equals 2. Okay, so we can undo that multiplication with division. What about then if we have a negative number being multiplied by x? I bring this one up specifically because anytime you're doing that operation with a negative, make sure you take the negative with the division. So you will divide by -7 on both sides. And anytime we're working with negatives, we just want to be really careful about the signs. So these cancel, the multiplication and division cancel. X is then by itself because I took and divided by the negative as well. -21 divided by -7 divides nicely, and a negative divided by negative is a positive. So my final answer is x equals 3. Okay, now let's deal with our last operation. What if we have a variable we're trying to get a loan that's being divided by a number in a linear equation? Here, x is being divided by 4. That means on both sides of this equation, I can multiply by 4. And again, I get that 4 over 4, which will simplify to 1, and those 4s will cancel. Then I'm left with x equals -2 times 4. Again, make sure you keep track of any negatives that are happening. That's -8. And I have solved my linear function. Okay, now as I mentioned, these first ones are the most simple because there was only one operation I had to undo that was happening to x. So let's start throwing in some more operations here. Here's one that's kind of hiding two operations. 4/5 times x equals 8. So you might be thinking, okay, how do I handle a fraction? Well, a fraction being multiplied by x is still, you can still think of that as just one operation. If I have 4/5 x, I can divide both sides by 4/5. Anything divided by itself is just 1. So I'm still left with x alone here, but now I have 8 divided by 4/5. Just make sure if you're doing that in the calculator, right? If you're plugging this into your calculator, which is what I would do, you say 8 divided by, and always put a fraction in parentheses if you don't have a fraction key in your calculator. Okay? When you do that, when you take 8 divided by 4/5, what do you get? You should get 10. Make sure you get 10. And this is a really good one to do that checking step, right? Our original equation was 4/5 x equals 8. Double check in your calculator. Does 4/5 times the answer we got, 10, equal 8? And it will be 4/5 times 10 equals 8. Okay, so we get down to 8 equals 8, and we know that that works, that this is in fact our final answer. Okay, so do that checking step. Anytime you're not sure if what you just did was the correct thing to do. All right, here's another way that fractions are often written with terms. So what if we had 2x divided by 3 equals 5/6? So this is where you can think, okay, a fraction is happening, but that's also like two operations are happening to x. We have multiplication here and we have division here. So you can think about undoing those operations separately. I always like to undo division first if I can. And here I can because if I multiply by 3 to undo that division by 3, those 3's will cancel. So that just means I need to do that to both sides of my equation. So then I would have 2x equals 5, 6 times 3. Again, you can do that in your calculator. Make sure that you use parentheses around your fraction, just as a default to make sure you do the math correctly, okay? And you should get 5 over 2 there. Then you have 2 times x. So then we need to divide by 2 on both sides to undo that multiplication of 2. Those 2's will cancel, and I'll have x equals, make sure in your calculator, again, take 5 halves divided by 2. Make sure you get the right answer here. You should get 5/4. Okay? And again, you could check your work there. You could plug that back into x in the original function and make sure you get the right answer. Okay? So when you take 2 times 5/4 and divide that by 3, do you get 5/6? And you should. All right, let's keep going. So that's another way to handle fractions. You can undo both operations at the same time, or let me kind of go back up to that one and tell you how we would have handled it like we did 6. Remember here with 6, we had a fraction times the exponent. So here we wrote this as 2x over 3. Oops. Equals 5 over 6. That's the same thing as 2 over 3x equals 5 over 6. And we could have handled this like number 6, and we could have divided both sides by 2/3. And when you take 5/6 divided by 2/3, you will get the same thing that you did here. Okay? So you can multiply by 3, divide by 2, or just divide by 2/3 to get rid of that. Okay. All right. Oops, I was trying to move that down and just ended up moving that. Okay. So let's look at number 8. For number 8, we're really going to throw in a couple more operations here. We're going to have 3x minus 4 equals 5. So now I have multiplication and subtraction happening to x. I always like to undo these operations kind of in the reverse order of your order of operations. Okay, so what we're going to do is always get the x term by itself first. So we will not divide by 3 first. We want to get that whole x term by itself first. So in order to do that, we are going to add 4 to both sides. That will easily cancel the subtraction of 4, leaving us with 3x, the x term by itself on the left-hand side, and 9 after we take 5 plus 4 on the right-hand side. Now is when we can say, okay, 3 is being multiplied by x, and now is when I can simply divide by 3 to undo the multiplication by 3 and end up with x equals 3. Again, you can always check your work here. Does 3 times 3 minus 4 equal 5? That's 9 minus 4 equals 5. That is 5 equal to 5, and it works out. Okay, so always undo that addition or subtraction first before you undo the multiplication or division. The reverse order, essentially, of the order of operations. Let's look at another one. 4x minus 6x plus 3 equals 15. Now this one kind of throws in a new step altogether. This one is not simplified from the beginning. So your kind of step 0 here is to simplify anything you can on one side individually if you can do it. So I'm not going to take an add 4 or something like that. That's a common mistake I see, because notice I'm not doing that on either side of the equal sign. Okay, So here, since 4x and 6x are currently on the same side of the equal sign, I am just going to combine like terms. 4x minus 6x is negative 2x. Then I still have my plus 3 equals 15. Once I have done that simplification step is now when I'll carry out the other steps. Now here I'll undo the addition before I undo the multiplication, so always undo that addition or subtraction first. I have addition of 3, so I'm going to subtract 3 from both sides of the equal sign in order to move that 3. That leaves me with negative 2x. These 3's cancel, that's why I subtracted 3. That equals 12. Now again, I have multiplication happening here between negative 2 and x, so I will divide by that entire term, by negative 2. When I divide by negative 2, all of that will cancel. I'm left with x, and 12 divided by negative 2 is negative 6. And again, you can plug that in back up here and make sure it works. Take 4 times negative 6 minus 6 times negative 6 plus 3 in your calculator and see if you get 15, and it does check out. All right. Let's do one more. You're going to get tons of practice with this in your homework. I again just want to give you several examples of ones that similar to ones you'll see, so you can kind of form a similar strategy to attack the problems you're going to be looking at. Now, this is the first one where we've seen x's on both sides of the equation. So what I would do here is you want to get x's on one side and numbers on the other. So you decide. I like to move my x's to the right-hand side. So I'm going to move my x terms to both be on the right-hand side. I'm sorry, I keep saying right-hand side, left-hand side. You could move the x and you could have added this x over instead. That's fine. Just do this one step at a time. Combine your x's somehow. Okay? So here, that cancels the x on this side, and negative x plus 4x will leave me with 3x. Bring down what's left. There's the plus 3, there's the equal sign, and then we have a 2 left on the right-hand side. As soon as we combine those x's together on one side, right now we have an equation that's very similar to ones we've already seen. I will undo that addition first by subtracting 3 from both sides. That will cancel that 3. 3x will then equal 2 minus 3 is negative 1. Make sure to keep track of those negatives. Divide by 3 since x is currently being multiplied by 3. And then we will be left with x equals, and I would leave that as a fraction, negative 1/3. Okay? So multiple ways we can attack these problems to solve them. But some key things there, always make sure you simplify on each side first. Get your x's on one side of the equation if you have x's on both sides of the equations. By doing the same steps, just move those entire terms, right? We were moving the entire 4x term, so we added that term over. Okay? And then from there, always undo your addition and subtraction before you undo your multiplication or division. All right, so give those practice problems a try in your homework. Do them until you get them all right, all right? Use those unlimited attempts that you have. Keep trying them until you get them all right, okay? The last thing I want to talk about is what they talk about in this section, which is your percentage application problems, okay? So these are problems where we need to set up the equation to be able to solve for these percentages, okay? So we want to dig into what's going on in these problems here. What's happening is that now we will have an unknown percentage. So we'll have an unknown of something we're multiplying by, and we need to solve the equation to find it. So one example I want to look at here, and you can take the time to get this down too, is here's our example. We're going to say that in a survey, 750 adults were against lowering the drinking age to 18. This was 74% of the people surveyed. Okay, so we know how many people said it and that was 74% of the total. What we're missing is how many total people were surveyed. So the problem is we always take percentages times the total. So even though I have the percentage here, I don't know the total. I just know that 74% of something is 750. So what you want to remind yourself of here is that you always take the total times the percent, and that equals the part, whatever part that percentage is representing. So here, we don't know the total. The total is our x, or our variable. So x times the percentage, always use it in decimal form, x times the percentage of 74% is the part, which was 750 adults, right? We knew that 750, this was 74% of the adults. So we have an equation. We have an unknown being multiplied by a number equals another number. And that's where we realize that we actually need to take 750 and divide by this percentage rather than multiplying by the percentage. We're used to knowing the total and multiplying by the percentage to find the part. But here we actually knew the part and the percentage, and setting up that equation shows us that we actually need to take the number we know and divide by 0.74 to get that total, which will end up being, if you round to the nearest whole number, if you take 750 divided by 0.74, we're talking about people here, so we want to round to the nearest whole number, that should be 1,014 total people surveyed. Okay? So you need to set up those equations and think through what's going on. What parts of the equation do you know? And then use those methods we just learned to solve linear equations in order to solve. Notice always to check your answer. So if you would have accidentally said 750 should be multiplied by 0.74, you would have ended up with a total number of people less than 750. How could we have surveyed less than 750 and gotten 750 responses? That doesn't make sense. So always rethink about the answer you've gotten in terms of the problem, and if it doesn't make sense, go back and check your math again. Okay, so see if you can try that again. You're also going to get more practice on the homework and in your activity, but I want to try to go over one more here. So this one says that a bus is at 75% capacity. Okay, that is with 48 people on board. Oops, see if I can spell that right. There we go. Okay, we're at 75% capacity with 48 people on board. And I want to know how many people can the bus hold? So again, I'm looking for the total number of people the bus can hold. So I don't know the total, that's going to be my x. My total times my percentage of 0.75, okay, should be what 75% of my total is. 75% of my total is a 75% capacity, and that is the part, which is 48. So again, I need to divide by 0.75 to get from the part back to the total. And x here then, again, since we're talking about people, we'll round to the nearest whole number, and we're talking about that the bus can hold 64 people total. That's the capacity of the bus. Okay, so use these equations to set up to help you reason through a problem. Set up your variable and then plug it into an equation that makes sense for the numbers you have. All right, give that homework a shot and ask my instructor questions, send me emails if you're stuck. Good luck, guys.